For those of us who don't study human health and disease or medicine, we almost always associate cancer cells to be different than normal cells because they replicate and grow quickly. Now, any cell that grows quickly and divides quickly means that it has elevated amounts of these chemical species, chemical toxic species that we refer to as reactive oxygen species. Now, elevated amounts of these reactive oxygen species causes cells to undergo stress. We refer to it as oxidative stress. Excessive amounts of stress, just like when you're stressed, could ultimately lead to cell death. Not in our case, thankfully. Now, we know, because we hear about it all the time, in that cancer cells have often found a way to continue on living. So this means that they've found a strategy to overcome this elevated amount of reactive oxygen species. Now, in cells, there are several systems that help to maintain this reactive oxygen species. One of these is the thyroid Auxin system. Now, because the important role that the thyroid Auxin system plays in maintaining this level of reactive oxygen species, and therefore alleviating this oxidative stress, a lot of research nowadays has centered around trying to target this system, creating inhibitors against this system as a means of drug therapy. Now, the thyroid Auxin system is based on the idea of two proteins, the thyroidauxin and thyroidauxin reductase, interacting together. This interaction, which you'll see in the slide on your left-hand side, is based on the idea that these two proteins come together. It's essential and it has to be conserved, regardless of what species it is. Now, in order to mimic the extreme cellular conditions that we often face in cancer cells, my research tries to focus on understanding the thyroid Auxin system from organisms that live in extreme environmental temperatures. Now, while my research isn't going to find a cure for cancer directly, by us understanding this protein-protein interaction, which is the raison d'etre of why this system functions the way it does, we can use this information to allow us to develop these drug targets, to develop this system as a means of inhibiting cancer. Ultimately, my research focuses on understanding the nature of the system, understanding why the system is so robust, and using this information for the benefit of mankind. Thank you.